This code removes outliers from numerical columns using Tukey rule and analyzes the impact on class distribution for loan status. And after cleaning, the code plots distribution of the loan status variable using a count plot and calculates the relative frequency of each class. And for the improved prediction quality, it first reduced noise. Outliers can distort the relationship between features and the target variables. Removing them ensures the model focuses on the core data distribution. And it has a better model generalization by training on clean data. The model avoids overfitting to extreme values, and it improves generalization to unseen data. And it enhanced class balance. Outlier removal can lead to a more balanced dataset, ensuring that predictions are not biased toward dominant classes. And for the correlation map, this code generates a correlation matrix heat map for the numerical features in the dataset. Here's a breakdown of the functionality. The line df select d types include np dot number, computes the Pearson correlation coefficients between all numerical columns. And for the improved prediction quality, its strongly correlated features provide insights into which variable contributes most to the target variable. Feature with low correlation can be removed to reduce noise. And for the multicollinearity detection, high correlation between independent variables can lead to multicollinearity, which affects model stability. Identifying subpairs allows for feature reduction. And by selecting the most relevant features and avoiding redundant ones, the model can focus on meaningful patterns, leading to faster training and better generalization. And for the adding new features through feature engineering helps capture more meaningful relationships between variables, improving the model's ability to distinguish patterns. Here's why this specific new variable improves prediction. For debt to income ratio, this ratio reflects borrowers' financial burden relative to their income. A higher ratio indicates higher financial stress, which correlates with higher default risk. The model gains a clear understanding of how affordable the loan is for each individual, enhancing prediction accuracy. And for the income per years of employment, this metric normalizes income by employment experience, highlighting whether a person's income is aligned with their career stage. It helps the model identify borrowers with stable experience-backed incomes, thus better in predicting their creditworthiness. And for the loan interest burden, this feature estimates the total interest cost of the loan, indicating the borrower's additional financial burden. And it improves the model identify borrowers who may struggle with repayment due to high interest expenses. And for the scaler, this code standardizes numerical features using standard scalar from uh, scales-learn. The standard scalar transform each numerical feature to have a mean of 0 and a standard deviation of 1. Many machine learning algorithms perform better with standardized features, avoiding numerical instability. And standardization accelerates the convergence of optimization algorithms, reducing training time, and features with larger scales can dominate others if not scaled. Standardization ensures that each feature contributes equally to the model. And for the SMOT, this code applies uh, Smoot to balance dataset by generating synthetic samples for the minority class. And the Smoot creates synthetic samples for the minority class, and X resampled, Y resampled generates the balanced dataset with equal class distribution. White matters because it improved model performance by balancing the classes ensures the model doesn't favor the majority class, leading to a fair and more accurate predictions. And here is the random forest class here. We train the random forest class here using the resampled training dataset. And we could see that the F1 score is 1. And here the part we tune this rainforest model to have a better performance. And we could see the parameter for the max depth is 20, and for the estimator is 200, and the random state is 42. And let's see the learning curve. This code defines a function plot learning curve that visualizes the learning curve of a given machine learning estimator. It evaluates the model's performance by plotting training and cross-validation scores as training set size increases. This helps identify issues like overfitting or underfitting. The shaded areas around the curves represent the standard deviation of the score, providing insights into the model's stability. And for this part, let's see the uh, confusion matrix. And this code generates a confusion matrix for the predictions made by XGBoost model. It compares the true labels with predicted labels. The confusion matrix is visualized using a heat map showing the number of the true positives, true negatives, and false negatives. This helps evaluate the model's classification of performance, highlighting areas where it makes correct and incorrect prediction. And for this part, we has the validation process, and through the validation process, we use this to improve our XGBoost model. And it's the first step that we train the XGBoost model and also the XTrees classifiers. So we have three models. The first one is random forest, and the second one is XTrees, and the last one is the XGBoost. And for the PR curve, these codes generates a precision recall curve for the XGBoost model. It first calculates the predicted probabilities for the positive class and then computes precision and recall values across different classification thresholds. The PR curve visualizes the trade-off between precision and recall, helping to evaluate the model's performance, especially when dealing with imbalanced data set. A higher area under curve indicating better model performance. And for the external data set that could enhance accuracy, I think it's a macroeconomic trends data such as unemployment rates or inflation rates and interest rates. These indicators can significantly impact their borrowers' ability to repay loans. For example, rising unemployment or inflation could increase default risk, while lower interest rates might improve affordability. Incorporating this data as additional features can help the model capture economic conditions that affect loan performance. leading to more accurate predictions.